Hello my dear students, this is Akash HD. Welcome to the ASD physics classes. Hope so you all are doing really great. So students, in this video we are going to solve the questions from the chapter Dual Nature of Radiation and Matter asked in a JEE 2024. Okay, so in this video we are going to learn how power, energy and time is related to each other, and even how this energy is responsible for the carrying the energy with the help of photons. Okay students, so let's start the video. So the question is what, kindly see here. Two sources of light emit with a power of 200 watt. How many sources of light is there? Two sources of light. The ratio of number of photons. Okay, photons came two times, one will strike out. So the ratio of number of photons of visible light emitted by each source having wavelength 300 nanometer and 500 nanometer respectively will be how much here. Okay, so after reading the question you can see very well that two sources of light is there and both of them are having power how much here, 200 watt is there. Okay, so first let's note down the data is this. So here this P1 equal to P2, what is this? They are having the power 200 watt. So from here we can tell very well for both the sources of light what is this? This P is constant. Now this power is constant. After that, next one, if I talk about here the wavelength, lambda 1. So lambda 1 how much is given here? Kindly see here the 300 nanometer. Okay, and second source wavelength is given here 500 nanometer. And what they are asking here? They are asking here the ratio of number of photons. Okay, so the ratio of number of photons means, let's take number of photons is capital N. So we have to calculate here N1 by N2 how much here. Okay, now after that here, this is the about the questions we have just written here the data and all that. After that we should know the formula. You know the formula, power is given by energy by time. What is given by? Power is given by energy by time. And you know very well here so many number of photons are there, is it? So each and every photon carries how much energy? Each and every photon carries energy h nu, is it? And nu is hc by lambda. Okay, so first let me write here. Let's take number of photons is n, and each and every photon is carrying how much energy? H nu, is it? H nu by T, is it? After that what will happen that here, remember that here even I can write here this power is given by N by T into H. Nu is given by, nu is the frequency, okay, and this frequency is given by C by lambda, is it? This nu I have written here C by lambda. In the question what we have to calculate? We have to calculate the ratio of number of photons. So from here if I make here the formula capital N, so formula of the capital M will be what here? Kindly see here Pt lambda, capital N how much coming here? See, Pt lambda by Hc, correct? See, this is the formula. This is the formula. N is coming how much here? Pt lambda by Hc. What are the things are constant? See, power anyhow constant, time they have not mentioned, so let's take they are talking about the same time now for source 1, source 2, they are taking for the same time how much is the ratio of the photons. So time is also constant, h is also constant because Planck's constant, c is the speed of light, that is also constant. That means what can it write here? The number of photons in a given time is directly proportional to lambda. What is coming? The number of photons in a given time is directly proportional to lambda. Okay, so hence we can write here, see, this n1 by n2 will come here lambda 1 by lambda 2, is it? After that what will happen that here, see, this lambda 1 is how much is there? 300 nanometer. Whenever we are taking the ratio, that means the unit should be same even, 500 nanometer. Then what will happen that here, see, this nanometer and this nanometer will cancel out, it will come here what? 300 by 500, is it? So we can write here hence the number of photons ratio in a given time interval. That time interval may be 1 second, 2 second, 3 second. Okay, so for the given source in a given time interval, the number of photons ratio is coming how much here? 3 by 5, is it? Can you see very well? Okay, and especially this formula here, is it? So which option is correct here? 3 by 5. The correct option is here option D. So students, I hope so this one, now this formula and especially this formula, now both these formulas are very important, is very clear to you. Kindly see very well. So students, I hope so this dual nature of radiation question is very understandable, and if in case this question came in a NEET exam, JEE exam, CBSE exam, you can do very properly. So students, keep studying, keep growing.